Hello, everyone. Welcome to this presentation of AgentSynth, Scalable Synthetic Task Generation by Jingxi Xie, Dylan Xu, Shandong Zhao, and Don Song. So, synthetic data, or using LLMs to generate training data for other LLMs, has become a popular area of research with regard to LLM agents for its scalability and potential to help automate LLM agent training. However, synthetic data sets often suffer from low quality, as LLMs cannot reliably complete tasks to produce the training data that we want for LLM training, right? It's a bit of a catch-22, especially in complex environments and complex tasks. So this is where the core idea of our method comes in. We start by proposing a simple task, having the LLM solve that simple task, and then propose a follow-up task, which the LLM then solves, and so on. So repeating this process produces a sequence of tasks that can be summarized by an overall long and complex task, which can be solved by a long and complex trajectory that in ways that would not be possible if we just tried to generate the trajectory given the task from the start, from scratch. So let's briefly go over this methodology. You can read about it in much more detail in our paper. So you have 6 agents. The task proposer agent proposes the initial task. Then the solver and the verifier do a sort of an actor critic setup to solve that initial task. The reviser, in case the task is not properly solved, then it revises the task to such that it is properly solved or that it makes it easier. And then the follow-up task, given that the initial task is successful, proposes a follow-up task. We then repeat this process, and then the summarized overall task is created by the task summarizer agent. Here you can read more about, or you can pause the video and read our pipeline in more detail. So we run our pipeline in 2 environments. The primary one is OS World, which provides a computer GUI via PyAuto GUI that an LM can interact with. The second one is Insta, which provides a text representation of websites and a set of actions that can be performed. So we create data sets on both to show the versatility of our method. And then here are some results. As you can see, sort of summarized tasks that include more tasks in the sequence get progressively more and more difficult, no matter which model you use, right? So this demonstrates that we can adjust the difficulty and create very difficult tasks and solve very difficult tasks in our data set. Additionally, our data set involves a wide variety of softwares and task topics that are used, you see in the charts. And then finally, our method is orders of magnitude cheaper than data sets that require humans to solve tasks from scratch, as you can see in the table. So overall, we use a task-by-task approach to create and solve difficult tasks from simple ones. Our method is difficult, cheap, and diverse, because as the number of subtasks increases, the possibilities of what the overall task could be branches and grows exponentially. We hope this pipeline will make evaluating and training LM computer use agents using synthetic data cheaper and more effective. All right, now let's briefly see our implementation. I'll show you the Insta pipeline. The OS World pipeline has a similar process. So here's a glance at the data set. Has the website, the task, the action sequence, and so on. And then as for the script, here's the script. All you need is you have to have the Docker container running and then run this Python command. And the rest is sort of taken care of. We have a GitHub where described in more detail. So, all right, thank you for watching, and I hope you have a good day.